It seems like we have an awful lot of prerequisite skills for this unit, but it's good for us to be reminded of things that we did in grade 10, and when we actually need it in this unit, I'll look at some of these things again. The next thing we're going to be looking at is factoring. Now, you spend an awful lot of time in grade 10 factoring, and so even with our prerequisite skills, we actually are going to spend a few days on this, just because you need to be able to factor in order to do something else for me. So this is factoring day one. And the first thing we're going to look at is, first of all, for you to recognize that factoring is just the opposite of expanding. So when we talked about polynomials and we talked about the distributive law, this is actually doing the opposite. So the first kind of factoring that we're going to look at is we're going to go from the least amount of work to the most amount of work. And that's why you want to look at every single question. You want to start with, okay, first of all, is there a common factor? Okay, if there is a common factor, that's what I do first, and that's usually the easiest. And then I move on to the next easiest, and we keep on progressing so that we actually are saving ourselves work. Now, factoring, you get better at factoring the more you do it. Okay, and this kind of, it's like a checklist in my head. So in my checklist, I always do look for a common factor first. Then I look for the next kind, and then the next kind, then the next kind. So it's a checklist that I literally go through. So a common factor is a number or a variable that is common for every term that we're talking about. So the easiest way is actually to do some questions here. So if I look at this first question, I have a 3x cubed minus 9x plus 27. Well, very easily I can see that there isn't a common variable because 27 doesn't have an x. Okay, however, even though there's not a variable that's in common, I can see that there is a number common to all three terms here. And you can see the number 3 goes into 3, it goes into 9 and 27. So that's the first thing I'm going to do. So remember, I'm not changing the value of anything, I'm just changing the look of it. So again, I'm going to start with my equal sign. I'm going to take out my 3. I'm going to put a bracket, and what I'm doing is I'm dividing each term by this number 3. Remember, it's the opposite of expanding, in other words, distributive law. So that's multiplying. So now we're dividing. So when I do that, I end up with x cubed. Negative 9 divided by 3 is negative 3x. And finally, my 27, so I'm going to have a plus 9, and I finish off with my bracket. So one way that I can easily check to see whether I factored correctly is I actually could do the opposite, and I could actually expand it. So I could actually multiply the 3 into each term in the bracket, and you notice we start with the question. Okay, the next one, again, I'm looking for a common factor. This time I have no numbers, all I have is variables, and you can see that both terms have an x, but actually they both have an x squared. So I'm going to take out an x squared. So again, I start with equals directly underneath x squared. And when I divide x squared out of the first term, I'm left with a y to the fourth. Now, I still have another term here because when I divide x squared by x squared, it doesn't equal 0, it equals the number 1. Okay, so if I had two terms and when I factor, I'm still going to have two terms when I take out a common factor. So that's the first checklist that I would look at. Then I move on to the next easiest. The next easiest is what we call the difference of or special squares. Now, when we're talking about special squares, I've gone through the common factors, and this is the next easiest. Okay, so we're looking for things that have perfect square roots. And so in my head, I'm thinking, okay, first of all, perfect square numbers. Okay, those are numbers like 1, 4, 9, 16, 25, 36, 49, and goes on and on and on. So I've dealt with those numbers before. I know that they're perfect square roots. So if I see that my question has that, it might be a special square factoring question. Now, squares, perfect squares, happen with variables as well. Okay, so perfect variable ones would be like x squared, x to the fourth, x to the sixth, x to the eighth. So actually, any variable to an even power will be a perfect squared variable. So when we're looking at these special squares, there are special ones within them. And the first one I look at is the easiest one, and that's the difference of squares. Difference of squares, I need two terms that are perfect squares. Okay, so they have to be either perfect square variables or perfect square numbers, and are separated by subtracting. So I need those things. Okay, so it's my checklist again. So if I look at the first question, and there's my thinking guy. Okay, first of all, when I see a question like this, I check for a common factor. Doesn't exist. Then my brain says, aha, there are two terms, and aha, they're separated by subtracting. It may be a difference of squares. Well, x squared. Well, that's a perfect square, and that perfect square is x. Square root of 4. Again, another perfect square. That's 2. So now it's just a matter of me having two brackets that are identical. One is adding and one is subtracting. And it doesn't matter which one you choose. So I take the square root of the first term, which is x. I take the square root of the second term, which is 2. Put them in brackets, two brackets, one adding, one subtracting. And again, it doesn't matter which bracket you choose for that. Let's look at another one. Okay, this one here. So this time my thinking guy is going to think. Okay, two terms separated by subtracting. Is x squared a perfect square? Yes, it is. And what about 121? Yes, it is too. And for some reason that doesn't want to show us. Come here, baby. Yeah, I do talk to my, oh, look at that. I can see something behind there, and I'm not quite sure what that is, so I'm going to make it disappear. So really, that's what I do. So the square root of that is x. The square root of 121 is 11. So again, I have my two brackets. I put x in the first position. I put 11 in the second position. One is positive and one is negative. And again, it doesn't matter which bracket you have for which. Okay, the final question on this page. Let's take a look at it. 4x squared minus 16. Ah, that's a perfect, and so's that. But did I check for a common factor? No, I didn't. And there is a common factor between here, and that is 4. So that's the very first step I have to do. So when I factor out a 4, I'm left with an x squared minus a 4. Then I look to see, can I factor it further? Well, yes, I can, because that's this one up here. So again, I'm going to keep my 4. I have my two brackets. The square root of x squared is x. The square root of 4 is 2. One is adding, one is subtracting. All right. Now, it is possible that I still have special squares, but it could be that I have a different kind, and that is what we call the perfect squares. And the perfect squares, I'm just going to bring up the slide thing for a minute. It's based on the following. It's based on these special patterns that we talked about when we talked about polynomial expansion. Okay, so really what I'm after is I'm trying to be able to recognize the answer so I can put it back to the question that we did before when we talked about special distributive law. So let's take a look. How do I recognize if they're perfect squares? This time there are three terms. There's a perfect square at the beginning and at the end, and the middle term is double a times c. Okay, so when I'm talking a times c, so I'm talking ax squared plus bx plus c. Okay, so we're going to do some examples like this, and you'll see that it's actually fairly easy too. So, first example, I'm looking at this one. It's x squared minus 10x plus 25. So my thinking goes, first of all, I have three terms. There's a perfect square at the beginning, right, because x squared. Square root of that is x. Square root of 25 is 5. And is the middle term, so this is what I have to figure out, is the middle term double a times c? So what often I do is underneath or on another sheet, I go square root of that is x. Square root of this is 5. I multiply them together, which now is 5x. And then if I multiply that by 2, do I get that middle number? Ah, 5 times 2 is 10. So yes, it is. So that means that this is a perfect square. So it means I have two brackets that are identical. So I'm just going to write one bracket and put a squared. I'm going to put an x in the first position, the 5 in the second. Now, to determine whether this is a positive or negative is going to depend on that b value. The b value here is minus 10, so I know that's going to be negative 5. If it said x squared plus 10x, then this would be a plus 5. Right, let's look at the next one. The next one, x squared plus 12x plus 49. Again, my brain goes and looks, hey, I have three terms. This is a perfect square. This is a perfect square. Now, let's check to see if that middle term. Always make sure you check because you never know. So that's an x. That's a 7. Multiply those together, and that's a 7x. Multiply them by 2, and 7 times 2 doesn't equal 12. It just doesn't equal 12. So what does that mean I have to do? It means that it isn't a perfect square. Okay, so it means that I need to try other techniques, and that will be from our next lesson that we're going to do. So again, checklist today. First thing I do, and I'm just going to go flip back here for a second so we can look at it. Common factor, I check for that no matter what. Then I look for perfect square numbers, okay? And if I have two terms separated by subtracting, and I have perfect squares, it's difference of a square. If I have three terms and I have perfect square at the beginning and at the end, I check to see whether their square roots multiplied by 2 equals the middle term. If it does, then it's a perfect square. If it doesn't, it means I have to do a lot more work. Okay, so tomorrow some worksheets just to help you practice it. And if you get that done, I actually probably have some factoring games too that you can try. So good luck.